Hello, my name is Marcus Baker. I am the developer behind the house lighting control system. The initial concept behind the house lighting control system was to design an Arduino and openHAB based 3-light system that can be turned on or off through a web page. The project aims to bring the power of home automation to your fingertips and control your home the way that you want to, without having to overpay for smart products such as bulbs, plugins, and switches. Products such as the Amazon Alexa or Google Home have become widely popular over the past few years, and home automation is a trend that will only grow in the future. The house lighting control system is a good introduction to the world of self-home automation and has the potential for growth in several areas. The system combines home automation with the products already available within your home, eliminating the need for a complete overhaul. On screen now is a product brochure that has all necessary information pertaining to the house lighting control system and will be linked in the description. If you have any further questions, my contact information can also be found on the brochure. If you have any unanswered questions, feel free to contact me or leave a comment down below, and I will get back to you as soon as possible. Today, we will walk through the project block diagram to get a better look at the individual components of the project and see how they all work together in a product demonstration towards the end of the video. On the screen now is the system block diagram, which shows us the required path that an input must take to get the desired output that we want. In this case, the input is the click of the computer mouse turning on or off a specific light, and the output is the correct light matching the desired outcome. As you can see, there are a couple things that must be done in between to get the input to an output. The first item on our block diagram is openHAB user interface and website. openHAB is an open source home automation software that allows the user to control their homes however they want to. openHAB is supported on all 3 major operating systems, Windows, Mac, and Linux, and also has support for iOS and Android mobile applications, but the mobile applications will not be covered as they are outside the scope of the project. From the openHAB settings, you can easily create different items to be controlled from the user interface, as well as check the status of our system, as well as our MQTT server. The user interface consists of 3 simple switches that determine the state of the physical lights. Since both our system and server are offline, turning the lights on or off from the web page has no effect at the moment. Next on the block diagram is the MQTT broker, which acts as the middleman between the technology and physical components of the project. A broker is another word for a server that continuously looks for signal inputs from openHAB and then sends that signal to our Arduino Uno to be interpreted. The version of the MQTT broker that is being used is one called Eclipse Mosquito, also supported on Windows, Mac, and Linux. Through my experience of implementing the program into the project, it was rather user-friendly. The MQTT broker must be hosted on a local computer that is connected to the same internet signal as the Arduino Uno. The program can run in the background of your computer and you would never know it is running, but my personal preference is to run it with logging to see if any errors occur while running the system. To initialize the broker, you need to navigate to the location where the program is installed and type one simple command that you can see on the screen now. We can now see that the server is up and running, and if we wait a couple of seconds, we can see the server ping openHAB. From openHAB, we can see that the server is also online. Once a signal is received from openHAB to the MQTT server, it sends that signal to the Arduino Uno via the internet. In order for the signal to make it to the Arduino Uno, it has to be connected to the internet, which cannot be accomplished by itself. An Arduino Ethernet shield must be used to connect to the internet. From the MQTT logging, it can be seen that the Arduino Uno has successfully connected when I plug in the power supply. We are now able to change the conditions of the lights. Before we go on and demonstrate the working system, let's talk about the brains behind the operation. A simple Arduino code was written that will come preloaded onto your Arduino Uno. The Arduino code connects to the internet upon startup and then loops endlessly, awaiting a single signal input from the MQTT broker. Once a signal is received, it is interpreted correctly and sorted further until an output command is reached. The Arduino outputs are connected to a relay board, which acts as the switch for the lights, turning them on or off based upon the signal input from openHAB. The written Arduino code is available upon request, and I will be happy to send it to you for personal use. The last thing to talk about before we see how the house lighting control system operates is the wiring of the physical components. There are three main wires that make up different power supplies. They are the Ethernet cable running from the Arduino Ethernet shield to the router, the Arduino power supply, which is just the supplied USB connected to an iPhone charging block and plugged into the wall outlet, and lastly is the light power supply. The light power supply is an old cable that was spliced, revealing a neutral and hot wire. These two wires were split into three separate wires respectively, using 14-2 gauge wire and marrettes, as we can see here on the floor. The three neutral wires ran directly to the lights, while the three hot wires ran into the common terminal of the relay board. This created a three-line parallel circuit where the power source was a 120 volt AC wall socket, and a respective light and relay occupied each line of the circuit. It was necessary to use 120 volt light bulbs to handle the voltage. Then, three more hot wires were ran from the normally closed terminal of the relays to the respective lights, where the relays acted as switches. An Allego 4-channel single-pole, single-throw 5-volt relay module was used to reduce the complexity of the project as well as increase organization and overall look of the product. It is important to note that when an input of 0 is sent from the Arduino, the relay circuit is closed, meaning that the light would turn on. Therefore, it is necessary to wire the relays in normally closed and not normally open configuration to account for this discrepancy and get the desired output instead of the inverse. Now that each individual component of the house lighting control system has been covered, it is time to see the system in operation. The system currently supports 3 lights, but there is potential for expansion, discussed in the project brochure found below. By selecting a couple of variations of the 3-light system, we can see that the 3 physical theoretical room lights replicate the state shown on the openHAB user interface. To see a full demonstration of all potential combinations of lights, please see my previous video where I test the house lighting control system thoroughly to ensure that it can handle all potential situations. Thank you for listening about my product, which I've put a lot of work into over the last 3 months. I hope I have inspired you to think about how home automation looks like in your own life, and hopefully I can be of some assistance. Have a great day.